Okay, so let's look at this type of triangle too, scalene triangle. Okay, and with scalene triangle, the type of triangle where we have different sides. Okay, all the three sides are not equal, none of them is equal. Okay, all the three sides are different. It means that each interior angle is also going to be what? Going to be different. Okay, so a scalene triangle can be like this. Maybe here is A, here is B, here is C, or different sides. Okay, and the angle will also be different. All right. So the angle here, if here is X, here is Y, here is Z, different interior angles. Okay, so we know that the area of a triangle is what? Half base times height. And if you are given an isosceles, okay, an isosceles triangle sometimes become easy to find because this side is the same as this side. So when you draw perpendicular height, the base will be divided into two, and then you use the Pythagoras theorem. Because equilateral two has the same approach. Because equilateral to these two sides are all the sides are the same, so automatically these two sides are the same, and then the base will divide into two equal halves, and then you use the Pythagoras theorem and find. Okay, with scalene, that is not the case. It is what? It is different. So if I want to calculate the area, okay, of a scalene triangle when I'm giving all the three sides, you see that way I cannot apply the same approach that I apply for what? Isosceles and then equilateral. Okay, so there is a formula that we use for the scalene triangle. Okay, when all the sides are different, we have a formula that we can use, and then we calculate for the area of what? Area of the triangle. Okay, so when you have a scalene triangle, which you know all the three sides are not the same, then we can use the Heron's formula. Okay, so the Heron's formula has or we use the Heron's formula to calculate what? The area of a triangle. Okay, so we go by the Heron's formula, or the Heron's formula. Okay, so this is what the Heron's formula says. It said the area of a triangle, okay, is equal to square root of s into bracket s minus a, s minus b, and s minus c. So this is the Heron's formula for the area of a triangle. S into bracket s minus a, s minus b, and s minus c. So what is the x? So where you can say that where the s is equal to a plus b plus c all divided by 2. Okay, so the sum of the perimeter when you divide by 2, that will give the s. All right, and then the a is the a, b, and the c is what? Is the three sides of what? Of the triangle that are not what? The same. So when you find the perimeter, okay, so the AB plus the perimeter of the triangle, then you divide by 2, that will give you the x. Then you substitute into the formula, and then you work. All right. So we are going to give example where the sides of the triangle are not the same. Okay. But before that, let's try and use an example with maybe an equilateral or an isosceles to test the Heron's formula for finding the area of a triangle. So let's say I have a triangle here. Let's say it's equilateral. Let's say my triangle is isosceles. Okay, this side is 5 centimeters, 5 centimeters, and let's say this side is 6 centimeters. So if I'm finding the area of this triangle, we know it to be very simple. Okay, so to find my height, so here will be 3 centimeters, here will be 3 centimeters. So we know that 5 square is equal to 3 square plus h square, and I have 5 square is 25, 3 square is 9, so minus 9 equal to h square. All right, and then my h will be equal to square root of 25 minus 9 give me 16, so h is 4. So my height is 4. So if I'm finding the area of this triangle, then the area is going to be half the base. The base is 6 times the height, which is 4. 2 goes into 6, 3, 3, 4, that will give me 12. So 12 centimeters squared. So the area of this triangle with dimension, this isosceles triangle 5, 5, and 6 is 12 centimeters squared. So I'm going to test, okay, the Heron's formula for finding the area. If I'm going to get the same answer, and then I'll see. So the Heron's formula says that it is a square root of s into bracket s minus a, s minus b, s minus c, where the s is what? Is the perimeter divided by 2. So if I'm taking this, then what is my s? Then my s is going to be 6 plus 5 plus 5, all divided by 2. So my s is going to be 16 on 2, and that will give me what? That will give me 8. So my s is 8. Therefore the area, I'll do my substitution to the formula, will be what? Square root of the 8 into bracket 8 minus a, so 5, 8 minus 5, 8 minus b, 8 minus another 5, and then 8 minus 6. Okay, so this is the dimension. The a, b, and c are the dimensions of what? Of the triangle. So my a is going to be 8 multiplied by 8 minus 5 will give me 3. 8 minus 5 will give me 3. 8 minus 6 will give me 2. So my a is going to be square root of 8 times 3 times 3 times 2. So let me check. 8 times 3 times 3 times 2. And that will give me 144. And what is square root of 144? That is 12. So 12 centimeters. You see? So you see that you have been able to use the Heron's formula to get what? To get the same answer. So find the area of a triangle with dimensions 8 centimeters, 7 centimeters, and 6 centimeters. So you see that if this is the triangle, okay, then 8, 7, 6, all the sides are not the same. So this is a typical example of what? A Scalene triangle. All the sides are not, and we are finding the area. Okay, so if I go by the Heron's formula, then my area is going to be square root of s into bracket s minus a, s minus b, and then s minus c. And then where the s is going to be a plus b plus c. So here my a is 8, b is 7, and c is the 6. So I'll have 8 plus 7 plus 6, all divided by 2. Okay, so what is 8 plus 7? That is 15. And then 15 plus 6 will give me what? Will give me 21. So 21 on 2. And what is 21 on 2? That will give us, I think, 10.5. 10.5. Okay. So therefore our area is going to be what? Square root of the s is 10.5, and then 10.5 minus 8, 10.5 minus 7, and then 10.5 minus 6. So my area will be equal to square root of 10.5 multiplied by, so you look at 10.5 minus 8, that will give us 2.5, minus 7, 3.5, and minus 6, 4.5. So our area will be 10.5 times 2.5 times 3.5 times 4.5. So 10.5 times 2.5 times 3.5 times 4.5, and that will give us 413.4375. And let's find the square root of 413.4375. And that will give us 20.3332 centimeters squared. So this is the area of the triangle. This is the area of the triangle using the Heron's formula. So when you get a scalene triangle, you can go by the Heron's formula and you get your answer. All right, let's meet again for more lessons. Okay, make sure to subscribe and go through the channel and learn more. All right, enjoy your day. Bye bye.